Okay, superposition. The first thing today I want to talk about is the superposition and see what it means. The superposition principles um, is a principle that you can use it, and you're going to use it in different fields of engineering. And here, just we look at that in electrical engineering to see how we can use it. And basically, what it says is that if you have some um, sources of the some sources, and then you want to see the effect of all these forces on single element, you can just I would say you can zero all the sources except one at the time and calculate the effect. Then go ahead and zero all the sources again except one and see the effect, and then add all the effects together. Um, let me put it a very simple example in case of, for example, the forces. Assume you have forces that create some effects. If you want to have, for example, you have three forces and you want to see what's the effect of them, you can go ahead and just look at the first forces, just assume the second and third forces is not there, and see the effect. And then go and only look at the second forces and see the effect. And then go and only look at the third forces and see the effect. And then if you add all the effects together, it's gonna give you the results as if you have all the three forces acted together. And this is how it's gonna work here. So assume we have three, for example, three batteries in the circuit. So we only keep the first battery and zero the second and the third battery, assume it's not there. And we calculate the current and voltage. Then we assume the assume the first and the third battery is zero, only we have the second battery. And then we calculate the effect of the second battery on the circuit, all the voltage and the current. And then we go ahead and assume there's only the third battery and there's not the first and second battery, and look at the effect. And then we add all those together. It's going to give us the result. So as a very simple, for example, if I have back, so if I have, for example, one source is here, whatever sources it's going to be voltage or battery sources, and then assume you have the second make it larger. The second sources, again, it doesn't matter if it's a battery or current, and then we have the third sources, and assume these are all connected to an element, whatever element it is going to be there. Again, we don't care. We have an element here, and we have these three connected to that. And then when I want to see what's happening here, first I would assume only S1, and I assume S2 is 0 and S3 is 0. And then I calculate, for example, I and V here. So I calculate I, it's going to be give me I1 and V1, whatever it's going to be. Then in the next step, I only consider S2 and assume S1 is 0 and S3 is 0. Only there's I assume only there's S2, and then I calculate the I2 and V2 at that element. Whatever value is that in element, I name it I2 and V2. And then again, in the third step, I only consider S3 and I assume S1 is 0 and assume the second source is 0. And then I calculate whatever current and voltage I get here. Gonna assume it's gonna be I3 and V3. Then when I want to see what's the I and V, then the I in this element is just adding I1 plus I2 plus I3, and the V is V1 plus V2 plus V3. Basically, it is the superposition. Just calculate I for each of the sources, calculate the V for each of the sources, and then just simply add them together. And then it's you superposition the effect of each forces on top of each other to build the entire one. So it's another method just to analyze a circuit. As we learned, for example, we had the node voltage method, or we have the mesh current method. This is another method of analyzing and solving a circuit. Go ahead and do that. Remember that we only zero independent sources. So we do not zero dependent sources. So if you have a dependent source, just leave it there. Don't worry about it. Only go ahead and zero independent sources one by one. So you zero all the independent sources but one at each step. Leave the dependent sources the way it is and work with them. Don't worry about it. So after we after that, after we and just as a reminder, when we have the voltage sources, if we have, for example, the voltage sources between A and B, so if you have voltage sources goes from between A and B and sources, so for example, Vs. If we want to zero the sources, what we need to do is just we have to go ahead and say Vs is 0. So to do that, remember, we just replace the voltage sources with the single wire. So if it was the A and it was a B, we just simply replace it with the single wire. So when we want to zero the voltage source. If we have the current sources, and assume, for example, it's point C, then there's the current sources, it goes to point D, as for example, it's IS. If we want to zero that, we want to zero the sources, it means the IS should be 0. It means that if you don't want any current go through the wire, just cut the wire. That's how you do that. So basically, we replace that with the open wire. So we just replace that with something like that. So it's going to be C, it's going to be D, and then this means there's nothing going there. So so to zero the voltage sources we had before, just replace it with the single wire. To zero the current sources, just replace it with the open wire. And that's how we zero the sources. Let's look at an example to see how we can use the superposition. A simple example. So assume I have the voltage sources like this. It's a 15 volt. And then it's connected to a resistance. So the 10 ohm. And then also assume there's a current going there. And then we have another resistance here. Second resistance is going to be 5 ohm. It's going to be R2 and it's going to be 5 ohm, and it's going to be positive, and we call this VT. And then we have this current source. That has a current of 2 amp. So assume this is what we have, and we want to analyze this circuit and, for example, find the value of the voltage here at this, I would say here, the VT. Assume that's what we want to find, or any other element in this circuit. So still, if we want to solve this circuit, one way of doing that, we can go ahead and use one of the previous methods we learned, the mesh current method, or node voltage method, or any other method that we know. But for now, we're gonna see how we can do that if we use the superposition method. So in case of the superposition method, what we need to do is that we are gonna just zero all the sources but one. So in other words, we keep one source at the time and then analyze the entire circuit, and at the end we add all the results we get. So to start, I'm gonna zero this current source, the very first part. So I assume the current source is gonna be 0, and then I will analyze the circuit. So if I zero the current source, so I'm gonna draw that again here. So the voltage source is gonna stay there still. So I have that 15 volts here. And then I have the R1. So the R1 is here. I have the R2. So it's going to be the R2. And then I want to zero this part. If I want to zero that, it basically what's that? We replace that with the open wire. So I just replace that with the open wire. So this is how I zero that one. So that's the first step. So in the first step, write it here. So the first step, I zero the current source, this current source here. Now I want to analyze this. So this is going to be my circuit. It's open, nothing goes there. I have this circuit here, and I want to find the voltage here. Remember, we want to find, eventually we want to find the voltage at this resistance. So we find the voltage here for the first step, then we zero the other one, we find the voltage, and we add them together. So if this is what I have, see, it's a battery and 2 resistance. It's a very simple circuit. It's battery, 2 resistance. And remember, we can easily use the voltage divider method to find the voltage here at this. So if I use the voltage divider method, it says that the V2, the voltage at this one, is going to be the proportional of these, I would say. So if I put it here, so it's going to be the R1 plus R2, and then it's going to be the R2, and the total voltage basically we have here times 15. So you can go back and look at the voltage divider method, how it works. But basically, the voltage is going to be divided in proportional of the resistance of those resistors. So therefore, the V2 from the first step, I would say the V2 from the first step. So the V2 from the first step is going to be, comes out as 5 volt. We do that. So it's going to be V2 from the first step. Let me make it look like 2 rather than Z. So it's going to be V2 from the first step. So that's how we get it. Now we are going ahead and zero the other sources. So first we zero this one. Now we are going to zero this one to see what happens. To zero this one, remember how we zero that. If we have the voltage source, to zero the voltage source, just replace it with a single wire. So I just remove that voltage source and replace it with a wire. So I'm going to have a single wire here. Then I have the R1 here. Then I have the R2 here. And the voltage here from the step 2. And then I have a current source here. So I just keep one source at a time. So previous time I removed the current source, now I remove the voltage source. And so it's going to be 2 amp. It's going to be 2 amp. So now I want to solve this circuit. If you look at this circuit, again, it's a very simple circuit. Look at the R1. If I move, I move the R1 and put it here, just move it along that line and put it here, then you will see the R1 and R2 is going to be parallel. So if I move the R1 along this line, this wire, and put it here, then R1 and R2 are going to be parallel, and then I can replace them with something like that. So I can replace them with the something like that. This one is going to be the equivalent, and it's going to be 2 amp. And then I know that if I have the parallel, if I have the resistance are parallel, the voltage in the equivalent one, whatever it is the same as is in each of those original ones. So the voltage here is going to be the same as the voltage in the original resistance because they are in parallel. The same is going to stay there. So here, that's again, I have a very simple circuit, and if I write the Ohm law, so I know the V2 from step 2 is going to be the I REQ, and I know the I and the R are these two parallel ones, so the REQ is also going to be 1 over R1 is going to be 1 over 10 plus 1 over R2, which is 1 over 5, and it's going to come at 3.30. So if I use these two, voltage as second step, the current is 2. I know that because of that source here is 2, and that's going to be 3.3. So it's going to give me 6.66 volt. And then if I want to know here, I'm going to write it up here. If you use another color. So here I know that VT is going to be equal to V2 from the step 1 from the V2 from the step 2. So it's going to be 5 volt plus 6.66 volt. So it's going to be 11.66 volt that we have. So this is how we calculate the voltage here. If we want to calculate the voltage for the R1, we can use the same strategy. If you want to calculate the current here or here, again, you can use the same strategy. Uh, uh, just keep one source at a time and find whatever you look for. And at the end, just add them all together to get the value you are looking for.